Hi, so this is our second lesson on differentiation with vectors. So in example 2, we're told that a particle moves in a horizontal plane at time t seconds. The velocity of a particle is given by this expression here as a vector. And for part A, we've been asked to work out an expression for the acceleration of a particle at time t. And then for part B, to use this acceleration to find the magnitude of a force when given that time is 3 seconds. Okay, so because we want to work out acceleration and we've been given velocity, we know that the acceleration will be dv by dt. So what this means is that we need to differentiate each of these components with respect to t. So if we begin with d by dt of the I component, 12 cos pi over 3 times t, well, we can differentiate this using the chain rule. So the derivative of the cos, the bigger function, will be minus sine. So this will be negative 12 times the sine of pi over 3 times t multiplied by the derivative of this inner function, which is pi over 3. So we can tidy this up then as negative 12 over 3 will give us negative 4 pi times the sine of pi over 3 t. And then differentiating the j component, again, we'll work out d by dt of negative 9t squared. We'll differentiate this with respect to t, and this will give us negative 18t. So the acceleration then, as a vector, will be negative 4 pi sine of pi over 3 t for the I component, and for the j component, negative 18t. And this will be in meters per second squared. Okay? For part B, the particle, which has a mass of 8 kilograms, moves under the action of a single force F newtons. So this moves under the action of a single force, tells you that we don't need to worry about any kind of friction. And we've been asked to work out the magnitude of a force when t equals 3. So we know that force is a product of mass and acceleration. And we have the acceleration as an expression here. And we can work out this acceleration when t equals 3 by substituting 3 into each of these I and j components. So we just write this out over here. When t equals 3, the acceleration will be, so if we substitute t equals 3 into this I component, well, this t will become 3, and we'll have 3 over 3 to make 1. And we know the sine of pi is 0. So this will become 0 for the I component, and then substituting 3 into the j component, this will become negative 18 times 3, so negative 54 meters per second squared. And because we're only looking at the magnitude, we know this will have a magnitude of positive 54. So we can substitute that back into our formula. So the force will be the mass we're given as 8 kilograms times the acceleration of 54 meters per second squared. And this works out as 432 newtons. Okay?